Okay, let's start with something. What if your home wasn't just smart because it reacts when you talk to it? What if it truly understood you? Like, not just hearing what you said, but actually seeing, perceiving what you were doing. Imagine, just for a second, a world where your tech intuitively anticipates what you need, adapting to your physical actions in real time. That's kind of the promise behind this really fascinating new initiative we're going to deep dive into today. Okay, let's unpack this. We're diving into Meta's groundbreaking Nymeria project. It's this colossal new data set, and it really looks set to redefine how AI perceives human motion, context, the whole shebang. So our mission for you today is to pull out the most important nuggets of knowledge from the sources we've looked at. We want to help you understand the just incredible scale of this thing, what's actually in it, and crucially, its potential, especially, for our smart homes and the wearable tech that's coming down the line.
Yeah, and what's truly fascinating here, I think, is that Nymeria feels like a significant leap. It's really about teaching AI to grasp human behavior, not just in some sterile lab setting, but in the wild.
Right.
Out in the real world.
Exactly. This isn't just making AI slightly smarter. It's aiming for something far more intelligent, more adaptive, genuinely helpful in our daily lives, because it learns from, the messy, unpredictable reality of how we actually live.
Stuff that labs can never fully capture.
Precisely. I think you're going to have some serious aha moments as we dig into how this data bridges that gap. The gap between our physical actions, picking something up, walking around, and a computer's understanding. It's about creating maybe a truly intuitive interaction.
So let's start right at the beginning. What exactly is Nymeria?
Okay, so at its core, Nymeria is this huge data set initiative. It comes from Meta's Reality Labs research. It officially kicked off around late 2024.
Right.
And its main goal, its fundamental purpose, is to push forward what they call egocentric human motion understanding. Egocentric. So from the user's point of view.
Exactly. First-person perspective. Literally what the person wearing the tech sees, hears, does. And this is, absolutely crucial for the next wave of AI, for wearables.
Like AR and VR headsets.
Definitely. And maybe even more importantly, for those AI glasses everyone's talking about.
Oh, okay.
What really makes Nymeria stand out, though, is its scale. It's just unprecedented, and the type of data. It's multimodal.
Multimodal, meaning
it captures lots of different types of data all at once, all synchronized, video, audio, motion sensors, all designed to capture the full spectrum of everyday human stuff through these wearables from that vital first-person view.
Wow. So it's like mapping the human experience moment by moment.
Kind of, yeah. It's a massive undertaking. And understanding the why behind it really brings it into focus. There are basically 3 core objectives driving this whole ambitious project, and each one tackles a pretty big limitation in AI and wearables right now. So first up, it's about improving full body motion tracking. This is a big one. Right now, VR, mixed reality devices, they really struggle to accurately capture your whole body's motion just from that first-person view.
Yeah, I can imagine. If the camera's on your head, how does it know what your feet are doing?
Exactly. It's what engineers call an ill-posed problem. We're trying to solve for unknowns, like trying to figure out a whole dance routine just by watching a tiny clip of someone's head bobbing. It's incredibly difficult.
Right.
You can't easily guess where your legs are, how your torso's twisting, where your hands are. So Nymeria's solution is to provide this incredibly rich, diverse data that lets algorithms learn to make much better guesses, to get accurate pose tracking, even with that limited view.
Okay, so the data helps fill in the blanks.
Precisely. And the relevance here is huge. It leads to way more natural, more responsive AR and VR experiences. Your virtual avatar actually moves like you, fluidly, in sync. No more of that awkward, jerky virtual movement. It's about proper embodiment.
That makes sense. So is it just the amount of data or something specific about the kind of data that solves that ill-posed problem?
It's definitely both. The sheer volume gives the AI tons of examples, all sorts of different situations to learn from.
Yeah.
But the type of data is critical too, especially having that ground truth full body motion capture alongside the first person view.
Ground truth, like knowing exactly how the body was moving?
Exactly. It gives the AI the answers, fills in those unknowns we talked about.
Yeah.
Which brings us neatly to the second objective, and this one is really exciting. Enabling context-aware AI assistance.
Context-aware.
Yeah. Nymeria takes this really unique approach. It combines the physical motion data with rich contextual info, and crucially, with natural language descriptions.
Language descriptions. How does that work?
They actually had human annotators watch the recordings afterwards and just narrate what was happening. Yeah. basically bridging that gap between raw actions, picking up a cup, and semantic understanding, picking up a cup to take a drink. It's not just labeling movements. It's teaching the AI the intent and the context behind even really mundane actions. The vision here is developing AI assistants that can observe what you're doing and respond appropriately, maybe even proactively.
So not just waiting for a command.
Right. Think about AI glasses. An assistant that recognizes, based on how you're moving, the sounds, what you're looking at, that it recognizes you're deep into cooking versus, say, just chilling on the sofa.
Okay.
And then it could adapt its behavior. Offer hands-free cooking steps, maybe set timers automatically, or if you're relaxing, it just fades into the background, stays quiet.
That's a huge leap from just voice commands. It's like true understanding.
Exactly. It's about the AI learning to predict or infer what you might need next based on your actual behavior, not just words.
Can it actually anticipate what you're about to do?
That's the goal, essentially. Building a predictive model of human behavior. And the third key objective ties into this. Advancing AR/VR user experiences themselves. Ultimately, it's about making avatars more realistic and interaction in mixed reality feel, well, real.
And the in the wild part is important here too.
Absolutely critical. Nymeria focuses relentlessly on real-world, in the wild human motions. This data isn't from some sterile lab. It's from people just living their lives, cooking, walking, working.
So it's more applicable to how we actually use this tech.
Precisely. It makes the AI more robust, more accurate in real user situations. The benefit: VR headsets, AR glasses. They can better predict and recreate your physical actions. Think smoother, more immersive experiences, like that virtual fitness coach idea.
Right, one that sees your exact form.
Exactly. Or virtual meetings where your avatar conveys your subtle body language, making it feel genuinely like you're there.
Okay, so let's tie this all together. What does Nymeria really mean for us, the users?
Well, fundamentally, Nymeria provides this massive, incredibly rich picture of daily human activity, all from that first-person view. It fills a huge gap in the data that was available before. It's diverse, it's synchronized across multiple sensors, and the scale is just enormous.
Right.
It's really about kickstarting innovation in wearables, AR, VR, AI. AI that fundamentally understands human behavior.
And the aha moment isn't just tracking movement.
No, the real breakthrough, I think, is teaching the AI the intent and the context. Moving from just seeing person lifts arm to understanding person is gesturing because they dropped their keys.
That semantic richness.
Yeah, that paired with the sheer scale of real-world data, that's the game changer. It's not just about what you say anymore. It's about what you do and maybe even why you do it.
Okay, this is where my mind starts to boggle a bit. The sheer scale. You said unprecedented?
Oh, yeah. Nymeria isn't just big. They're calling it the world's largest egocentric human motion data set.
Okay, quantify that for us. How big is big?
We're talking roughly 300 hours of recordings.
300 hours?
Yep. Collected as 1,200 separate sequences, each one about 15 minutes long.
Wow.
And the diversity, get this, 264 unique participants.
Okay.
Across 50 different locations. And it wasn't just random filming. It was designed around 20 unscripted scenario categories.
Unscripted, so just real life.
Pretty much. Think about the range. Normal indoor stuff like cooking, tidying up, just relaxing. Then outdoor things like hiking, biking, even social stuff, playing sports, eating in a cafeteria, working in an office.
So a bit of everything.
Exactly. It gives incredibly broad coverage of daily movements. The idea is to give the AI a really holistic, real-world view of how we move and interact, not just lab movements. And to capture all that, they used, like I said, the symphony of sensors. It's quite the setup. And every single device was time synchronized down to sub-millisecond precision.
Sub-millisecond. Why is that so important?
It's absolutely crucial for correlating actions. You need to know that this specific body movement happened at the exact same instant as this specific eye gaze, captured by this specific video frame.
Ah, okay. Otherwise, it's just a jumble of unrelated data.
Exactly. Like trying to piece together a movie when all the sound and picture reels are out of sync. It just wouldn't work. So let's break down these data streams. First, the full body motion capture. Participants wore a professional XN's inertial motion capture suit.
Like they use in movies?
Similar tech, yeah. It provides ground truth 3D skeletal poses, super accurate, at a 240 hertz.
240 times a second?
Yep. That captures really subtle movements, tiny shifts in weight, muscle twitches, details you need for realistic avatars or, say, analyzing fitness form. Precisely.
Okay.
And then this raw data, this super detailed motion capture, was mapped onto a standard humanoid model using Meta's own tool called Momentum.
Why map it?
For consistency. Make sure everyone's data is in the same format, same skeletal structure, which makes it easier for AI models to learn from all the different participants.
So they're wearing Hollywood-style mocap suits while just cooking dinner. That's wild. How did they capture the user's view amidst all that gear?
Right. That's the egocentric vision and sensors part. For that, they wore Meta Project Aria smart glasses.
Okay, I've heard of those. Research glasses, right.
Exactly. Pretty sophisticated.
Yeah.
They capture multiple things at once, all synced. You get forward-facing video, both color, RGB, and grayscale. That's literally what the wearer sees.
Yeah.
Crucially, they also capture eye-tracking video and data.
So you know exactly where they're looking.
Precisely. What they're paying attention to in any given moment. Huge for context. Plus, you get multi-channel audio from built-in mics and onboard sensors. IMU for orientation and movement, magnetometer for direction, barometer for altitude.
Wow. So it's the full sensory experience from their point of view.
Pretty much putting the AI right in their shoes, yeah.
And you mentioned wrist devices too. How did they fit in? Seems like a lot already.
Good catch. Yeah, they also used wrist-worn wearables. 2 custom ones, actually, called Nymeria wristbands.
Nymeria.
Yeah, basically the same advanced sensors as the Aria glasses, just packed into a wristband form factor, one on each wrist.
Okay, and what do they add?
They record their own IMU data and other sensor readings. This is vital because your hands and arms, often hidden from a head-mounted camera.
Right, if you're reaching down or something.
Exactly. So these wristbands provide extra data for figuring out fine motor skills, gestures, how you're interacting with objects. It really complements the head and full body data for a more complete picture.
Right.
And then, for even more context, there was also a third-person perspective.
An observer.
Yeah. For each recording session, someone else was there, also wearing Aria glasses. This gives an external, time-synced view of the whole scene, like a regular camera's view, but perfectly synced up.
Why do that?
Super useful for understanding the wider scene context, what's happening around the participant, and also for validating the egocentric data. Does the first-person view match what's happening from the outside? It provides another angle.
Okay, so user's view, full body motion, wrist motion, and an external view. That's a staggering amount of data. How on earth do they pull all that together? It feels like it would be chaos.
That's where the derived 3D environment data comes in. This is kind of the magic glue. Meta used their machine perception service, MPS, running on the Aria devices. It generates things like 6 due trajectories for each device, the headset, both wristbands.
6 to F, 6 degrees of freedom.
Yep. Basically tracking the exact position, X, Y, Z, and rotation, pitch, yaw, roll, of each device in 3D space over time.
Okay.
And MPS also generates semi-dense 3D point clouds of the surroundings using SLAM.
SLAM. Simultaneous localization and mapping.
You got it. It's like the device is constantly building a 3D map of the room while also figuring out exactly where it is within that map.
Wow.
So what this does is unify all the motion data, head tilt, wrist flick, body pose within a single consistent 3D space. Everything is perfectly aligned in the context of the real-world environment. It's like the master choreographer for all the data streams.
The complexity there is just mind-bending, pulling all that together. But maybe the most distinctive part, the bit that really jumps out, is the power of language, those natural language annotations you mentioned.
Yeah, this is huge.
It's not just sensors and numbers. They had people actually describe the actions.
That's right. After the recording, annotators narrated what was happening. And at different levels of detail, too. So you get like really fine-grained descriptions of tiny movements, but also simple labels for basic actions and even higher-level summaries of the whole activity.
That adds a whole layer of meaning, right? Context that numbers alone can't give you.
Absolutely. It's the semantic layer.
And the scale of these annotations. You said it was massive.
Over 310,000 sentences, which works out to something like 8.6 million words describing the actions.
Whoa.
This makes Nymeria the world's largest motion language paired dataset. It explicitly connects physical action with how we talk about it.
So it enables research right at that intersection, movement and language.
Exactly. And like we said, the real aha here isn't just labeling. It's teaching AI to grasp the intent and context. Moving beyond person lifts arm to understanding why person gestures for attention.
Because they drop their keys.
Yeah.
That semantic richness feels like the secret sauce.
It really could be. It lets AI build a much more nuanced understanding than just observing motion ever could.
Yeah.
And underpinning all of this is a serious focus on ensuring quality and usability, which is vital for a dataset this complex. We talked about the hardware synchronization, less than 1 millisecond drift, which is incredible, and the spatial alignment using SLAM, mapping everything to that single 3D world frame.
Right.
They also took significant privacy measures. This is super important. Faces and license plates in the videos, blurred using Meta's own ego blur algorithm.
Okay.
And crucially, everyone involved, the participants wearing the gear, the homeowners, if recording was in a private residence, gave explicit informed consent.
Good. That's essential.
Absolutely.
Yeah.
It ensures the integrity and research value while respecting privacy. Paramount with this kind of personal data, the sheer data volume and format are also worth noting again. It's about 70 terabytes total.
70 terabytes?
Yeah. Which breaks down into over 201 million images, billions of IMU samples, 260 million pose timestamps, plus all those annotations.
That's a lot to download.
It is, which is why usability is key. It's organized smartly into sequences and data groups by modality. So you don't have to download all 70 terabytes. You can filter and grab specific subsets using tools they provide.
Ah, okay. So I could just get, say, kitchen sequences, IMU data, and annotations.
Exactly. If that's what your project needs. It's designed to be manageable, despite the crazy size. Just to quickly recap the key dataset statistics, because the numbers are pretty staggering. 1,200 sequences, 300 hours, 264 people, 50 locations, 20 scenarios, resulting in 260 million 3D poses, 201 million camera frames, 11.7 billion IMU readings. Billion with a B. About 10.8 million eye gaze samples. Participants traveled nearly 400 kilometers combined just based on head movement during recording. And add those 310,000 plus narrated sentences. Yeah, unprecedented is the word.
Truly, not just big data, but like meticulously curated big data about us.
Exactly, an unparalleled resource for building next-gen intelligent systems.
Okay, let's shift gears a bit and unpack this further, because the potential here goes way beyond just cooler VR games, right? It seems like this could directly impact our daily lives, especially inside the smart home.
Absolutely. This is where Nymeria could have a really tangible impact, creating smart homes that truly understand you, leading to genuinely context-aware assistance.
Okay, how so?
Well, think about combining that egocentric video, what you see, with all the sensor data from your body and those activity annotations. You can train AI to recognize in real time what a person is actually doing in their home.
Like not just that someone is in the kitchen, but that they are cooking?
Exactly. Or cleaning. Or relaxing. Or exercising. The source material gives these specific examples. The AI learns the subtle differences in motion, gaze, sound.
Okay. And then what? How does the home respond?
This is where it gets cool.
Oh.
Imagine the possibilities. You go home, stressed from work, slump onto the sofa. Before you even think about the lights or music, the house senses that shift from active commute to relaxing. Maybe the lights subtly dim, your favorite chill playlist starts, the thermostat adjusts slightly.
All without a command.
All without a command. Because the AI understood your physical cue. Or you start moving around the kitchen. It might recognize cooking prep patterns and proactively offer to preheat the oven.
Oh.
Or suggest a recipe based on the ingredients it sees you looking at. Or, just as importantly, if it detects you're on a work call, maybe based on posture, lack of movement, audio cues, it just stays quiet.
Once they interrupt, maybe silences the doorbell.
Exactly. And those language narrations, they're key for training this. They help the AI link sensor patterns to descriptions of actions, which makes the conversational AI part much better too. So the bigger picture, Nymeria fuels context-aware automation, homes that are sensitive to what you're doing, not just what you say. Truly anticipatory.
That is a massive shift. My current smart home stuff mostly just waits for me to tell it what to do.
Yeah.
Nymeria sounds like a potential gold mine for human activity recognition algorithms.
Definitely.
Models that can accurately spot things like sitting on sofa, walking upstairs, cooking, maybe even looking for keys.
Precisely. And in a smart home, these models are vital for things like occupant monitoring, safety, and wellness.
Give me some practical examples. How would that work?
Okay, so an AI trained on Nymeria could learn your typical daily routines from motion sensors or cameras.
Right.
Then it could spot anomalies, like maybe a sudden fall detected by unusual acceleration patterns.
Ah, like for elderly care.
Exactly. Or maybe unusual inactivity when someone normally would be moving around. It could trigger an alert to family or caregivers.
That could be life-saving.
Potentially, yeah. Or even simpler stuff, logging activities for fitness tracking, accurately counting reps during a home workout just by watching you, estimating calorie burn based on how intensely you're moving. And again, because Nymeria uses in the wild data, real homes, real activities. The AI models are more robust. They're better equipped to handle the messiness of real life compared to models trained only in perfect lab conditions. More reliable. And this also feeds directly back into transforming VR in your living room. More immersive home experiences. Nymeria significantly improves that full-body avatar representation we talked about, making interactions feel real, even with minimal hardware.
So better virtual meetings from home.
Could be. Or imagine future smart home mixed reality stuff. A virtual fitness coach that mirrors you accurately, gives real-time feedback on your form right there in your living room.
Like they're actually there.
Yeah. Or telepresence, where your avatar truly represents your body language in a shared virtual space. Much more natural connection. The source material even mentions this method, HMD2, remember, using just the headset sensors to estimate the full body pose.
Right, that sounded amazing.
It's a potential game changer for home use. It means future consumer AR/VR might not need extra cameras dotted around your room for body tracking.
Oh, that would be huge. Less setup, less clutter.
Exactly. Makes full body tracking much more accessible, less intrusive for just, normal homes, bringing that immersive presence anywhere.
The applications just keep stacking up. What about personalized wellness? Posture, fitness, ergonomics.
Another great fit, that rich motion data. Incredibly useful for posture monitoring and coaching tools.
How? Like using sensors in your chair.
Could be. Or sensors in a smart band, or even just the AR glasses themselves. Imagine your home office setup. The system detects your slouching and gives you a gentle nudge, visually or audibly.
Okay.
Models trained on Nymeria, which has data of people working, exercising, stretching, even just lounging, could learn good versus bad posture. Analyze your exercise form for tiny corrections, maybe even spot repetitive strain movements before they cause real problems.
Wow. Like a preventative AI physio.
Sort of. It could lead to much more accurate ergonomic assessments, smarter fitness apps.
A home personal trainer AI that really knows how you're moving.
Exactly. For remote workers, maybe gentle reminders to stretch or adjust seating, making daily life healthier, more comfortable automatically. And let's link this back to language again. Nymeria is crucial for bridging the gap. Multimodal interaction and language understanding. It helps build AI that can seamlessly translate between movement and words.
Translate movement to words. How?
Well, imagine a smart home interface where you perform a gesture, maybe swipe your hand in the air, and the AI interprets that as dim the lights.
Instead of saying it, more intuitive sometimes.
Could be. Or the other way around. The AI could verbally describe what someone is doing.
Why would that be useful?
Think monitoring, maybe checking in on kids or an elderly parent. Or huge for accessibility, assisting visually impaired users by describing activities happening around them. That tight integration of motion and narration in the dataset enabled this model called Ego-M. It's a framework that directly combines body motion understanding with language. Models like that could be the brains of future smart home robots or assistants, ones that observe you, understand what you're doing and why, and then respond appropriately, maybe even conversationally. True understanding again.
And while we're focused on the home, this obviously has wider horizons, general AI wearable applications.
Absolutely. Beyond the house, think future smartwatches or AR glasses software.
Okay, like what?
Models trained on Nymeria could interpret data from the sensors already in those devices, leading to stuff like automatic workout recognition. Your watch just knows you started doing push-ups or yoga, no need to log it.
Yeah, that'd be nice.
Or advanced gesture control, maybe snapping your fingers turns on music. Things beyond simple taps.
Yeah.
And proactive reminders. Your AI glasses see your movement patterns, maybe combine it with other sensor data, and realize you left the fridge door open.
Huh. Need that one.
Right. A subtle visual nudge. Nymeria is explicitly mentioned as beneficial for developing these next-gen AI glasses and smartwatches. It provides that real human motion data needed to make their algorithms truly smart.
So this raises the question, what's the overall impact here? What's the big takeaway? In essence, Nymeria helps make smart homes and wearables far more responsive and adaptive, sensitive to the people within them. By training AI on this incredibly rich real-world behavior, we move towards truly intelligent environments. Environments that don't just react, but understand human context, intent, subtle cues.
Improving convenience, safety, the whole experience.
Exactly. Transforming our homes and devices from just tools into something more like empathetic, understanding companions, intuitively aligned with how we actually live.
Okay, I'm betting some listeners, especially developers or tinkerers, are thinking, right, how do I get this?
Yeah.
Let's talk about navigating the data, accessing and downloading Nymeria. First thing, that's 70 plus terabyte size. It's daunting.
It is, but the good news is you probably won't need the whole beast for any single project.
Meta was smart about access. They have this Dataset Explorer web interface.
Yeah.
That's your starting point.
Okay, a website.
Yeah. It lets you browse sequences, select specific ones, even preview snippets like video clips or motion traces before you download.
That's really useful. Lets you see what you're getting.
Exactly. Helps you pinpoint the exact sequences and data types, modalities relevant to your smart home idea or AI experiment. Saves a ton of time and bandwidth.
And the actual download process, how does that work?
Pretty straightforward, actually. You need to sign up on the official Project Aria website.
Okay.
And you have to agree to the license, the Creative Commons Attribution Non-Commercial 4.0 International CC BY NC 4.0 license.
We'll definitely circle back to that license. It sounds important.
Critical.
So once you're signed up and agreed...
Two main ways to get the data. You can do manual selection, just grabbing individual files or sequences. Good for quick tests.
Right.
Or for bigger projects, you do a batch download. You request a list of URLs in a JSON file. They're usually valid for a couple of weeks. Then you use a Python script they provide, download.py. It's on their GitHub to fetch all the files in bulk. It even organizes them nicely for you, designed for efficiency. Okay, so you've downloaded some data. Now what? Understanding the developer's toolkit. Understanding formats and tools is the next step. Some raw data might be in specialized formats, like VRS format, which is Meta's internal thing for Aria devices.
Sounds complicated.
It can be, but you don't necessarily need to become a VRS expert. The key resource is the Nymeria Dataset GitHub repository.
GitHub repo. Got it.
Yeah, Facebook Research and Aria Dataset. It provides an API, basically, code tools in Python. Tools specifically for loading, parsing, and even visualizing Nymeria data. Like there's a viewer.py script.
What does that do?
Lets you play back sequences, seeing the 3D motion capture synced up with the first-person video. Really helps you understand what's in the data quickly. And definitely pay attention to the documentation there, the reame file, definition.py, sequence attributes.py. They explain the file structure, coordinate systems, everything you need to interpret the data correctly.
Makes sense. Read the manual.
Pretty much. And if you really want to go deep on the Aria device specifics, there's the broader Project Aria Research Kit, ARK, and Project Aria tools. But for most uses of Nymeria itself, the dataset repo tools are probably enough.
Okay, practical steps then. How do you actually use this to start building your smart home AI?
First step, selecting relevant modalities. Like we said, you don't need everything. Be strategic.
Right. Less data is faster to process.
Exactly. If you're building, say, an activity recognizer for a smartwatch, maybe you only grab the IMU data from the wrists and head plus the annotations. Skip the massive video files.
Okay.
If you're doing a vision-based thing for a home camera, maybe you grab the third-person video and the egocentric video for relevant scenarios, like cooking or cleaning.
And then you train your models.
Yep. For activity recognition, you'd feed those sensor streams, like IMU data, into your machine learning model or neural network, using the narrated activities as the labels, the answers for what was happening.
Okay.
For vision systems, you use the videos to train action detection models. And that third-person view is great because it's similar to what a fixed home camera sees.
Good point. Makes it transferable.
Right. And don't forget those language annotations. You can use them to train or fine-tune language models to describe human behavior from video or sensor data. Super useful for accessibility or reporting features.
What about hardware considerations? Nymeria uses fancy research gear. Can models trained on it work on my phone or smartwatch?
That's a great question. And often, yes, they can transfer surprisingly well. The type of data from, say, Nymeria's IMUs isn't fundamentally different from the accelerometer gyroscope in your watch.
Ah, okay.
And because Nymeria's data is so diverse and in the wild, models trained on it tend to generalize better. They're more robust when faced with the slight differences in sensors on consumer devices.
So the real-world nature helps.
Big time. Finally, for experimentation and prototyping, especially if you're working alone or with limited computing power, start small. Grab a few sample clips using the Dataset Explorer. Play around with the provided code. Maybe try to replicate a baseline result from Meta's paper. Get your feet wet before trying to boil the ocean, you know. Okay, we absolutely have to talk about the license, what you can or cannot do. This is crucial. Nymeria is released under the Creative Commons Attribution Non-Commercial 4.0 International License, CC BY-NC 4.0.
NC BY-NC 4.0. Okay, break that down.
Okay, BY means attribution. You must give proper credit to Meta and the Nymeria project if you use it.
Makes sense.
NC means non-commercial, and this is the big one. You are free to use, share, adapt the data in code. but only for non-commercial purposes.
Non-commercial only. So what does that mean in practice?
It means academic research, education, personal experiments, hobby projects, all good. Building a product or service that you sell, or using it in any commercial venture, absolutely not allowed under this license.
Right. So no building the next big smart home app based directly on this data and selling it?
Not without a different license or explicit permission from Meta, no. This license is strictly for nonprofit, research, educational uses.
Got it. And you have to cite the paper if you publish research using it.
Yep. And if you share or adapt the data, you have to keep the same CC BY/NC license terms. You also can't try to de-anonymize people. That's a big no-no. Respect the participants.
Which brings us squarely to ethical considerations and responsible use. This data involves real people, even with the blurring and consent. It feels like there's a big responsibility here.
Absolutely. Meta did their part with anonymization on consent, but the responsibility extends to anyone who uses the data. The call is for responsible use. Focus on aggregate analysis, model training, advancing the science, not on surveillance, not trying to identify or target individuals. That would be a serious misuse.
So even if you could potentially figure something out, you ethically shouldn't try.
Precisely. Honor the spirit of the data release, which is for research and innovation, while respecting the privacy of those who contributed.
And just to reiterate, if you build an amazing AI model with this, you can't just spin it into a commercial product under this license.
Correct. Non-commercial is the key restriction. It's fundamental, both legally and ethically.
Yeah.
Looking ahead, what are the future implications and calls to action? Well, the access process itself is pretty open. Registering on the Project Aria site is straightforward. There isn't some heavy vetting process.
So it is accessible for independent developers, students, hobbyists.
Very much so, which is great for broadening the research community. Meta also mentioned potential updates, maybe new annotations, reprocessing. If you register, you should get notified. And you might see workshops or challenges pop up in conferences using Nymeria as the basis. Keep an eye out for those. But really, connecting it to the bigger picture. Nymeria isn't just a pile of data. It feels like a foundation for a future where AI understands us more deeply.
Yeah.
Not just through commands, but through our actions, our context, our behavior.
Yeah.
It's really an invitation to the research community, to developers, to hobbyists, to explore how technology can genuinely adapt to human life, how it can become less of a tool we command and more of a system that understands and anticipates, blending more seamlessly into our lives. #outro pressure.
So let's try and wrap this up. What does this all mean? We've taken a really deep dive into Meta's Nymeria project today. We've explored its just staggering scale, 300 hours, hundreds of people, real-world scenarios, and its incredibly rich multimodal data, everything from pro-level motion capture to first-person video, eye tracking, and even, crucially, natural language describing what people are doing. We've seen how this resource is really designed to accelerate innovation in AI and wearables. And the potential, especially for smart homes, feels immense. We started off imagining that home that understands your actions, not just your words. Nymeria is actually laying the groundwork for that.
It really is. Nymeria helps pave the way towards homes that aren't just collections of smart gadgets, but truly intelligent environments. Environments that understand and adapt to us. It lets us genuinely imagine a world where tech intuitively aligns with how we naturally behave, making life maybe not just easier, but feeling more connected, more understood by the spaces we live in, almost like the house itself is a thoughtful companion.
So thinking about that, what specific unspoken command or subtle action are you most excited for your future smart home to finally get now that you know a data set like Nymeria is out there trying to teach it? Something to think about. We really hope this deep dive has given you a powerful shortcut to understanding this exciting development. Thanks for joining us on the Deep Dive.